Hi there. Today we are going to be looking at how to factor the sum and difference of cubes. This is a special factoring formula. We haven't looked too much at cubic polynomials yet. We focused mostly on quadratic polynomials. So I want to build a little bit of an intuition first about how cubic polynomials might function. Let's start out with some x plus 1 and we'll square this. Okay, if we square this, well, we know what this formula should look like. This is the square of a sum. So this should give us some x squared plus 2x plus 1, right? So this is what we'll get here when we square it. But what would happen if instead we cubed it? Okay, so if we cube this, now let's try and see what's going to happen. Well, this is essentially going to be this is going to be an x plus 1 multiplied by an x squared plus a 2x plus a 1, right? It's because this is x plus 1 squared. And if we do that, then what we're going to get is, well, we're actually going to get some kind of x cubed plus 3x squared plus 3x plus 1. Okay, now we actually learned how to do this before. Okay, we learned this pattern where we do the cube of a sum. But if you don't remember, or if you don't believe me, we can actually solve for this, right? So what we can do is we can essentially distribute. We'll distribute this term into the parentheses here. So this is the same as x times all of this plus 1 times all of this. Okay, so let me write that down. It's going to be the same as x times all of this, right, plus 1 times all of this, okay? And so let's do the arithmetic here. So if we do x times all of this, what do we get? We'll get an x cubed plus a 2x squared plus an x, right? We're just distributing the x into the parentheses. And then we'll do the same thing here, but that's pretty easy. Distributing the 1 in, that doesn't really change that. So what we're going to wind up with is exactly this, right? And we can line up the like terms, in this case the x squareds and the x's, just like that. And we can add these together then. We add them together, we see we're going to get an x cubed plus a 3x squared plus a 3x plus a 1. So just as expected, this is what we get when we cube x plus 1, okay? Now, the reason I put this out there is because I want you to sort of see that we can have some kind of cubic polynomial and we can factor that. We can break it into two pieces. We can factor it into a binomial multiplied by a trinomial, some kind of linear factor multiplied by a quadratic factor. And it turns out that this is always going to be true. You can always factor a cubic polynomial into the product of a linear and a quadratic polynomial, right? So that's sort of the essence, the point that I wanted to get here, build our intuition here. We can sort of say that if you have some kind of a3 x to the power of 3 plus a2 x to the power of 2 plus a1 x to the power of 1 plus a0, this can always be broken into the product of a binomial and a trinomial, right? So the binomial we'll say is some kind of b1x plus b0, right? A linear one here. And then this would be, let's say, some c2 x squared plus c1 x to the first power plus c0, okay? And so this is always going to be true. You can always do this. All right, let me show you that idea here, and we're going to build on this idea just a little bit to look at a very special case for a cubic polynomial that we're going to learn to factor. So here's the formula that I want us to learn. This is essentially the special factoring formula. We're going to learn that if you have a cubic polynomial of some form a cubed plus b cubed, you can split that into this binomial multiplied by a trinomial factor, okay? Let's justify this, right? Let's actually do this. So I can show you why this actually works. So this will essentially be, if we factor this into the parentheses, this will be equal to a times this plus b times this trinomial. Okay, so let's write it down. This will equal some a times a squared minus ab plus b squared. And that'll be a plus ab times, again, all of this, okay? Now notice what's interesting here are the signs, right? It's a cubed plus b cubed, and here it's a plus b. Everything here is positive except for this middle term, which is negative, okay? And so we kind of want to remember that this linear term will match the sign here, and then this middle term of the quadratic, that's going to be the opposite sign of whatever you had there, okay? But let me highlight that here, okay? So these are sort of the opposite signs. We want to try and understand like why that needs to be a negative sign here, like how this actually works out, right? Okay, so let's actually do the arithmetic here. So I'm going to factor this a into the parentheses. I will get an a cubed minus an a squared b plus an ab squared. Okay, so that's what I get here. And this comes from the product with this negative signed middle term. Next, I'm going to distribute rather this b into the parentheses here. So that will give me now a b times a squared, that's an a squared b. Then I get b times a negative ab, so that'll be a negative ab squared. And then finally I get a b cubed at the end. And this is the term that is the resulting product from multiplying this times b. Okay, and now what do? Well, I'm going to add these two together just like that. Notice here that these cancel out and these cancel out. So I'm going to be left with just an a cubed plus a b cubed, right? And that is exactly what we were trying to achieve. We're trying to demonstrate that these two forms are equivalent, and in fact they are. Okay, so this is the formula here that you can use to sort of simplify how this is all going to work. Let me give you an example. Let's work on this example here. If we have x cubed plus 8, well, I want to imagine this as the sum of two cubes. So I'm going to imagine this as an x cubed plus a 2 cubed, all right? Now, in that case, if we sort of follow the formula that we have right here, this should be equal to an x plus 2 multiplied by, well, this will be an x squared minus a 2x plus a 2 squared, which is a 4. Okay, and this is what we should expect to get here as our factor result. And let's check. Okay, let's multiply these two together. So we're going to sort of distribute this term into the parentheses just like that. We'll wind up with an x multiplied by this quadratic plus a 2 multiplied by that same quadratic. Let's do the arithmetic. This will give us an x cubed minus a 2x squared plus a 4x. And on the bottom, we will get a 2x squared minus a 4x plus a 4. Add that together. Yes, in fact, this will be an x cubed plus a 0 plus a 0 plus a 4. It works. This is going to be then the factored form of this original expression here using this sort of formula for the sum of cubes, the sum of two cubes here. Now, sometimes you might also be able to factor this quadratic. Okay, in this case, you can check we're not going to be able to factor this quadratic, but sometimes you might be able to. Okay, so it's always worth checking. Let's look at the difference of cubes now. So here we have the difference of cubes, and it's a very, very similar formula, just some sign differences. So it's a difference here, so we have a difference here, and where we had a negative sign before, now it's positive, okay? So that's sort of what we're looking at here, and we can, of course, demonstrate why this is going to work. So let's take this term and distribute it into the parentheses, so it'll be an a times this minus a b times all of that. Okay, so let's do that. We'll have an a times an a squared plus an ab plus a b squared. And that'll be a minus b times all of that. Okay, so let's do the arithmetic here. We see we'll get on top an a cubed plus an a squared b plus an ab squared. And on the bottom, well, let's think of this as distributing a negative b into the parentheses. That might be the easy way to do this. This will give us a negative a squared b, so a negative a squared b, and then a negative ab squared, negative ab squared, and then finally a negative b cubed. Just like that. And so now when we add these two together, yeah, sure enough, these are going to cancel out and we'll just be left with an a cubed minus a b cubed, which is exactly what we were hoping to achieve here. Okay, so this formula does in fact work. Let's try looking at an example here. Okay, how about x cubed minus 27? Okay, so I want to express this as the difference of two cubes. Okay, so I'm going to say this is x cubed minus 3 cubed. Okay, that's 27 right there. So given that, I should have as my factored form a linear factor multiplied by a quadratic factor. My linear factor then should be x minus 3, and my quadratic factor should be x squared plus 3x plus 3 squared, which is 9. Okay, let's double check. Let's make sure that this works. Okay, so I should get here an x multiplied by all of this, and then a negative 3 multiplied by, again, all of this. Okay, so once again, let's do the arithmetic. On the top, we'll get an x cubed plus a 3x squared plus a 9x. And on the bottom, we will get a negative 3x squared, a negative 9x, and a negative 27. And when we add this together, sure enough, these two terms are going to cancel out. We'll be left with an x cubed minus a 27, exactly what we were hoping to find. So this here is going to be the factored form of x cubed minus 27. All right, let's just try a few examples to wrap this up. Here we have a x cubed plus 1. Now this is interesting. I want to think of this as the sum of two cubes. So I can think of this as x cubed plus 1 cubed, because of course 1 cubed is 1. And so this will allow it to fit the pattern. Here I expect to get x plus 1 multiplied by my quadratic factor. Here should be an x squared, a minus 1x, and then a plus 1 squared, which is 1. Okay, so this is what I expect to get here. Let's multiply these together, right? Let's distribute everything. What are we going to get? We'll get an x multiplied by this quadratic, and then plus 1, again, multiplied by this quadratic there. What is this going to give us? This will give us an x cubed minus an x squared plus an x. And then on the bottom, this doesn't change because we're just multiplying by 1. So let's line that up here. Like that. And I think we can add these together. Notice these are going to cancel out. And so we will be left with an x cubed plus a 1, exactly as we expected. So yes, this is going to be the factored form of our x cubed plus 1. Let's do the last one. Okay, this is going to be the last one for today's lesson. We want to, again, think of this as some kind of difference of two cubes here. Okay, so what is this going to be? This will be a 3x quantity cubed minus, well, this is the cube root of 125 is going to be a 5, right? So that'll be a 5y quantity cubed. And so here we have sort of our a and our b, and we know that this should follow some kind of factor where you get a minus b here, so that'll be a 3x minus a 5y. And then the quadratic here, we expect to get a 3x, okay, let me make these into brackets. So we'll get a 3x quantity squared. And then everything here will be a plus 3x times 5y. And then finally, plus we have a 5y squared, and that's all going to be inside this bracket. So let me simplify that. Okay, this becomes a 3x minus 5y multiplied by, this becomes a 9x squared plus a 15xy plus a 25y squared. Okay, so this is what I expect to get for my factored form. Now let's check it. we'll have a 3x multiplied by this, and then a minus 5y also multiplied by this. Okay, it's getting a little bit messy, but I should be able to do it. Let's just draw a line here. Okay. What we get on the top here, 3x times 9x, that's going to be a 27x cubed. 3x times a 15xy. Okay, so 3 times 15 is 45, so that'll give us a plus 45x squared y. Next, we have 3x times 25y squared. 3 times 25 is 75, so this would be a plus 75xy squared. Now we're done with the top. On the bottom, then, we're multiplying this negative 5 times 9 here, so that'll be a negative 45. Negative 45x squared y. The negative 5y and the 15xy, that'll be 15 times 5. I think that's going to be, yeah, that'll be 60 plus 15, 75. So that'll be a negative 75xy squared. And finally, this negative 5 times this 25, that will give us our negative 125y cubed. We combine everything together. Sure enough, these two terms are going to cancel just like that. We'll be left with a 27x cubed minus 125y cubed. That is exactly what we were looking for right over here. So yes, this is going to be our factored form as expected. All right, so it works. These are the formulas for the sum and difference of two cubes. Okay, so there you go. That's how you're able to implement this formula to factor the sum or difference of two cubes. Okay, now we've learned about quite a lot of these different special formulas. We learned about the difference of two squares. We learned how to factor perfect square trinomials. And today we learned how to factor the sum and difference of two cubes. So we should practice this a little bit more. That's what we're going to do next time. We're going to practice using all of these special formulas. So come back then, and I will see you there.